Top 25 Docker Interview Questions and Answers. In the competitive landscape of software development, Docker has become an essential tool for containerization. This video presents a comprehensive guide to the top 25 interview questions and answers that candidates may encounter when applying for Docker-related positions. Whether you're a novice or an experienced professional, these questions will help you assess your understanding of Docker concepts and practices. Prepare to enhance your knowledge and boost your confidence for your next interview. 1. What is Docker, and how does it differ from traditional virtualization? Docker is a containerization platform that allows developers to package applications and their dependencies into standardized units called containers. Unlike traditional virtualization, which involves running multiple operating systems on a single physical machine through hypervisors, Docker containers share the host operating system's kernel. This leads to faster startup times and reduced resource consumption. Containers are lightweight and portable, making it easy to move applications across different environments without compatibility issues. This makes Docker ideal for microservices architecture and continuous integration deployment workflows. 2. Can you explain the architecture of Docker? Docker's architecture consists of several components that work together to create, manage, and run containers. At its core, Docker includes the Docker engine, which is a client-server application. The client communicates with the server, the Docker daemon, using a REST API. The daemon is responsible for managing containers, images, networks, and volumes. Docker images are immutable snapshots of a file system, while containers are instances of these images with runtime configurations. The architecture also includes Docker Hub, a cloud-based registry for sharing and managing images. Networking in Docker allows containers to communicate seamlessly, and orchestration tools can manage multi-container applications, enhancing scalability and reliability. 3. What are Docker images, and how are they different from containers? Docker images are lightweight, standalone, and executable packages that include everything needed to run a piece of software, including the code, runtime, libraries, and environment variables. They are read-only templates used to create containers. In contrast, containers are instances of these images that can run, modify, and store data. While images are static and immutable, containers are dynamic and can change when running. This distinction allows containers to be created, started, stopped, and deleted without impacting the underlying image, promoting efficient resource use and rapid deployment. 4. How do you create a Docker container from an image? To create a Docker container from an image, you use the docker run command followed by the image name. For example, docker run dp80-80 nginx creates a new container from the nginx image, running it in detached mode and mapping port 80 of the host to port 80 of the container. You can specify additional options such as environment variables, volume mounts, and network settings as needed. If the image is not available locally, Docker will automatically pull it from Docker Hub or the specified registry before creating the container. 5. What is the role of Docker Hub? Docker Hub serves as a cloud-based repository for Docker images, enabling developers to share and manage containerized applications efficiently. It allows users to publish their images, making them accessible to others, which fosters collaboration within development teams. Docker Hub hosts a vast library of pre-built images, facilitating quick application deployment. Additionally, it offers features such as automated builds, webhooks for integration with version control systems, and private repositories for secure image storage. This platform simplifies the process of sharing and distributing containers in various environments. 6. Explain the difference between Docker Run and Docker Start. Docker Run is used to create and start a new container from a specified image. It combines the two steps of creating a container and starting it into a single command. With options, you can also configure the container's environment, ports, and volumes at the time of creation. On the other hand, Docker Start is used to restart an already existing, stop container. It does not create a new instance but simply resumes execution from where it left off. Docker Run is ideal for new deployments, while Docker Start is useful for managing existing containers. 7. How do you share data between the host and a Docker container? To share data between the host and a Docker container, you can use volumes or bind mounts. Volumes are managed by Docker and stored in a part of the host file system that is isolated from the container. They are ideal for persistent data. You can create a volume using the command docker volume create _volume_name greater than and then attach it to a container using the v option, like this. Docker run v _volume_name greater than container _path greater than. Bind mounts, on the other hand, link a container directly to a specific path on the host system. This can be done with the same v option, but specifying the host path, e.g., docker run v host_path greater than container _path greater than. Using these methods allows for efficient data sharing and persistent storage between the host and containers. 8. What is a Docker file, and why is it important? A Docker file is a text document that contains all the commands to assemble a Docker image. It specifies the base image, application code, dependencies, and environment settings required to create a container. Each instruction in a Docker file creates a layer in the image, making it efficient and reproducible. Using a Docker file is important because it allows developers to automate the image creation process, ensuring consistency across environments. This leads to easier deployments, better collaboration among teams, and simplified version control for application environments. 9. How do you optimize a Docker image to make it lightweight? To optimize a Docker image and make it lightweight, start by choosing a minimal base image, such as Alpine Linux. This significantly reduces the image size. Next, utilize multi-stage builds to separate build dependencies from runtime essentials. Remove unnecessary files and packages after installation to decrease bloat. Use Docker ignore file to exclude files not needed in the image. Layering efficiently by combining commands in a single run statement can also help minimize the number of layers, which reduces size. Finally, regularly review and update images to remove outdated components. 10. What are Docker volumes, and how do they work? Docker volumes are persistent storage mechanisms used to store data generated and used by Docker containers. Unlike the container file system, which is ephemeral and lost when a container is removed, volumes exist independently of containers. They are stored on the host file system and can be shared among multiple containers. Volumes allow for easier data management, backup, and transfer. To use a volume, you can create it with the Docker volume create command and mount it into a container with the v or mount option during container creation. This setup ensures data persistence across container lifecycle events. 11. Can you explain the concept of Docker networking? Docker networking refers to the way containers communicate with each other and with the external world. Each Docker container has its own network stack, allowing for isolated communication. Docker provides several networking options, such as bridge, host, and overlay networks. The bridge network is the default. It allows containers on the same host to communicate. Host networking gives containers direct access to the host's network stack. Overlay networks enable communication between containers on different hosts, making it essential for multi-host setups in orchestration tools like Docker Swarm and Kubernetes. 12. How do you link multiple containers together in Docker? Linking multiple containers in Docker can be accomplished using Docker networks or legacy linking. The preferred method is to create a user-defined bridge network, allowing containers to communicate using their names as host names. To link containers, you can create a network with Docker network create less than network underscore name greater than, then start containers with the network less than network underscore name greater than flag. This enables them to resolve each other's names. In legacy linking, you would use the link flag. However, this method is deprecated and not recommended for new applications. Using networks promotes better isolation and flexibility. 13. What are Docker Compose and its main use cases? Docker Compose is a tool designed for defining and running multi-container Docker applications using a simple YAML file. It enables developers to define all services, networks, and volumes required for an application in a single file, streamlining the process of setting up and managing complex applications. Main use cases include orchestrating microservices architectures, managing environment configurations, and simplifying local development setups. It allows users to run multiple containers with just one command, ensuring that all dependencies are correctly configured and started together, which enhances productivity and minimizes errors during development and testing. 14. How would you scale applications using Docker Compose? Scaling applications using Docker Compose is straightforward. You can define the number of container instances for a specific service in your Docker Compose.yaml file using the scale option or by specifying the replicas under the deployment configuration in newer versions. For example, if you have a service named web, you can scale it by running Docker Compose up, scale web equals 3, which will create 3 instances of the web service. This method allows you to efficiently manage resources and improve application availability by distributing the load across multiple containers. Adjusting the number of replicas can help meet varying demand without significant reconfiguration. 15. What is the difference between Docker Swarm and Kubernetes? Docker Swarm and Kubernetes are both container orchestration tools, but they have distinct differences. Docker Swarm is simpler and integrates seamlessly with Docker, making it ideal for users with basic orchestration needs. It allows for easy management of clusters and is user-friendly. Kubernetes, on the other hand, is more complex but offers advanced features like automated scaling, load balancing, and self-healing capabilities. It supports a wider range of configurations and can handle larger and more intricate deployments. Kubernetes is often preferred for enterprise-level applications due to its robust ecosystem and community support. 16. How do you monitor resource usage in Docker containers? Monitoring resource usage in Docker containers can be achieved using several tools and techniques. Docker provides built-in commands like Docker Stats, which shows real-time information about CPU, memory, network I/O, and disk I/O for running containers. For more advanced monitoring, you can integrate third-party tools such as Prometheus, Grafana, or cAdvisor, which offer detailed metrics and visualizations. These tools can help track container performance over time, set up alerts for resource limits, and analyze usage patterns to optimize applications. Regular monitoring is crucial for maintaining application health and ensuring efficient resource allocation. 17. What are some common Docker security best practices? 1. Use official images. Always pull images from trusted sources like Docker Hub to reduce vulnerabilities. 2. Limit container privileges. Run containers with the least privilege necessary. Use the user flag to avoid running as root. 3. Regularly update images. Regularly check for and update images to include security patches. 4. Scan images for vulnerabilities. Utilize tools to scan images for known vulnerabilities before deployment. 5. Use Docker secrets. Store sensitive data, like passwords, using Docker secrets to avoid hardcoding them in images. 6. Implement network segmentation. Isolate containers using networks to minimize exposure to potential threats. 7. Enable container resource limits. Set limits on CPU and memory usage to prevent denial of service attacks. 8. Monitor container activity. Use monitoring tools to track container behavior and detect anomalies. 9. Avoid unnecessary services. Minimize the attack surface by removing unnecessary services from containers. By adhering to these practices, you can significantly enhance the security posture of your Docker environments. 18. How do you handle environment variables in Docker? In Docker, environment variables can be handled in several ways. You can define them directly in the Docker file using the env instruction, which sets default values for variables within the container. Another method is to use the e-flag with Docker run, allowing you to pass environment variables at runtime. Additionally, you can utilize Docker Compose files to specify environment variables in the environment section. This approach aids in keeping configuration settings flexible and separate from the application code, enhancing security and portability across different environments. 19. What happens if a Docker container crashes? How can you recover it? If a Docker container crashes, Docker automatically stops it and marks it as exited. You can recover it by restarting the container using the docker start command. If you want the container to restart automatically on failure, you can set a restart policy when you create the container with the restart flag. This ensures that the container is restarted under specific conditions, such as on failure or when the Docker daemon starts. Additionally, you can inspect the logs using Docker logs _id greater than to diagnose the issue that caused the crash. 20. How do you troubleshoot issues inside a running container? Troubleshooting issues inside a running container often involves several steps. First, check the container logs using Docker logs _id greater than to identify any error messages. If the application is unresponsive, you can access the container's shell for deeper investigation using Docker execute _id greater than bin bash. This allows you to run diagnostic commands, examine configuration files, or test network connectivity. Additionally, using tools like Docker inspect _id greater than can provide detailed information about the container's configuration, resources, and environment variables that may be affecting its performance. 21. What are the benefits of using Docker in a CI/CD pipeline? Docker streamlines continuous integration and continuous deployment (CI/CD) processes by ensuring consistency across development, testing, and production environments. It allows developers to create isolated environments for applications, minimizing "works on my machine" issues. With Docker, teams can automate testing and deployment, leading to faster release cycles. Its lightweight nature enables quick spins of containers, facilitating parallel testing. Additionally, version control for images allows easy rollbacks to previous states, enhancing reliability and reducing downtime during deployment. This adaptability supports agile methodologies effectively. 22. Can you explain the lifecycle of a Docker container? The lifecycle of a Docker container involves several key stages. Initially, a container is created from a Docker image using the Docker create or Docker run command. Once created, the container transitions to the running state upon execution. During its active phase, it can execute applications and respond to requests. If a container requires updates or changes, it can be stopped and restarted. Upon completion, the container can be removed with the Docker erm command. Throughout its lifecycle, containers can also be paused or resumed as needed, allowing for flexible management of resources and workloads. 23. How does Docker help in microservices architecture? Docker significantly enhances microservices architecture by providing lightweight, isolated containers for each service. This isolation allows developers to build, test, and deploy services independently, facilitating continuous integration and continuous deployment (CI/CD) practices. Docker's ability to package applications with their dependencies ensures that services run consistently across different environments. Additionally, Docker's orchestration tools, like Docker Compose and Swarm, simplify the management of service interactions, scaling, and networking. This modular approach enables teams to innovate rapidly and efficiently respond to changing requirements. 24. What are the differences between Docker images and virtual machine snapshots? Docker images are lightweight, portable, and consist of a layered file system, allowing for efficient storage and quick deployment. They encapsulate an application and its dependencies, enabling seamless sharing across environments. Conversely, virtual machine snapshots capture the entire state of a virtual machine, including the operating system, applications, and data, which makes them larger and slower to create and restore. While Docker images facilitate rapid scaling and deployment of applications, VM snapshots are better suited for backup and recovery scenarios. This distinction offers flexibility in managing application lifecycles. 25. Why do companies prefer Docker for application deployment, and what advantages does Docker provide over other containerization tools? Companies prefer Docker for application deployment due to its lightweight nature, speed, and efficiency. Docker containers start quickly, allowing developers to deploy applications faster than traditional virtual machines. Its portability ensures that applications run consistently across different environments, reducing the "works on my machine" problem. Docker's extensive ecosystem, including Docker Hub for sharing images and Docker Compose for managing multi-container applications, simplifies the development process. Additionally, Docker's strong community support and integration with CI/CD tools make it a popular choice for modern software development practices. In exploring the top 25 Docker interview questions and answers, we've seen how essential Docker has become in modern software development and deployment practices. Mastering these questions can significantly enhance your chances of acing your next interview and demonstrating your expertise in containerization. We hope this video has provided you with valuable insights and a deeper understanding of Docker. If you found this content helpful, please like the video and subscribe to our channel for more informative discussions and tutorials. Thank you for watching.